So these rational exponents, if you look at the word rational, you'll see at the front of this word is ratio, and a ratio is just a fraction. So whenever you see rational, just think fraction. All right, so rational is just another word for a fraction. A rational number, it's a number that can be written as a fraction. Now, fractions have two parts, a numerator and a denominator. So if you have a term with a rational exponent, each of those pieces have a part to do with a radical, actually. Essentially, you take the denominator, which the denominator is the bottom, always remember, I think denominator, I see the D, I think down, denominator is down, it's the bottom part of the fraction. So that denominator, you actually move it. It actually goes from underneath the denominator of the exponent and moves in front of it and becomes the index of a radical, which is insane to think of. So the denominator becomes the index of a radical, even when there wasn't a radical to begin with. Nice and easy. The numerator, which is the top of the fraction, you don't do anything with it. You leave the numerator right where it is. That's still your exponent. Whatever the numerator of that fraction is, you leave it alone. So all we do is if you ever see a fraction for an exponent, just take the bottom of that exponent's fraction and you move that number in front and you make it the index of a root. So it's really one thing that we're doing. And of course, we're going to look at some examples. Okay, so we're looking at fraction as exponents. And the fraction has two parts, numerator and denominator. Numerator stays put, but that denominator, that thing on the bottom, that's going to move out in front. Here's a nice illustration of what I mean. So up top, I've got 27 to the 1/3. This is 27 to the 1 over 3. So if I take that, I see, hey, 27 to the 1/3 power. That means that, well, there's a rational exponent because 1/3 is the exponent, but it's a fraction. We've never seen those before. All you do is take a look at that numerator and denominator, the 1 and the 3. And so this 3, this denominator, it actually moves out in front of that term, in front of the 27 in this case. It becomes the index of a root. So it's the same as so an exponent of a 1/3 is actually the same thing as a cube root. It's crazy. That numerator of that 1, look how that just stays there. You don't do anything with it, okay? So all you need to worry about or focus on, numerator stays put, just take that denominator and move it in front and make it a radical. Then you no longer have a really weird fraction for an exponent. Then simplify it if you can. For example, the cube root of 27 is 3, because 3 times 3 times 3 is 27. So that's the easy part, just moving the denominator out in front. But now you have to think about, okay, well, what does this actually mean in terms of the answer or the number, or how can I simplify this? For example, we know the cube root of 27. We could simplify that down to a 3. And actually, that was 27 to the first power. Well, what if it's a bigger exponent? That could get pretty big. Well, here's the good news. Do you see my two examples here on the left side and the right side? See how it's both the square root of 4 to the third power? But I've written them a little bit differently. On the left side, it's kind of like I've got the square root of 4 first, like figure that out, and then you cube that answer. Where over here, it's like I'm taking 4 to the third power first, and then taking the square root. So it's like that exponent, is it under the radical or is it outside of the radical? The good news is it doesn't matter. You'll get the same answer both ways. So take a look on the left side. If I were to take the square root of 4 first, well, we all know the square root of 4 is just 2. But there's still that exponent out there, right? That 3 is still hanging out. And we know 2 to the third power, well, 2 times 2 times 2 is 8. So when we took the radical first, we got an 8. Now let's take a look at the other side. This side's saying, hey, figure out what 4 to the third power is first. So that's 4 times 4 times 4. Well, 4 times 4 is 16. 16 times 4 is 64. Do any of you know what the square root of 64 is off the top of your head? Yeah, that's just an 8. Do we get the same thing? Yes, we do. So the good news is order does not matter when you're taking a root or taking it to an exponent. My suggestion is, if you can, always take the root first, because that's going to give you a smaller number. And I know I prefer to work with smaller numbers as opposed to going up to a bigger number and then trying to figure out the square root of some gigantic number. So I would suggest always taking the root first if you can. All right, so 25 to the 3 halves. Here we have a rational exponent of 3 over 2. There's a numerator and there's a denominator. So the numerator is the 3. The 3 stays put. So it's still going to be 25 to the third. The 3 stays exactly where it is. The part that changes is that denominator. We're going to move it out in front and make it a root. All right, so that 2 is going to move out in front of a radical. And that 2 becomes the index. In this case, it's really nice because an index of 2, isn't that just called a square root? This is really, hey, what's the square root of 25 to the third power? Now here's a nice example where you can see how it's nicer to take the root first before the exponent. So I could take 25 to the third power, but like off the top of your head, do any of you know what 25 times 25 times 25 is? I don't. I think it's like 6,000 something. Some crazy big number. But then once I get this crazy big number, I'm going to have to try to figure out the square root of it. Clueless. But instead of that, do any of you know what the square root of 25 is? Yeah, you all do. That's just a 5. So I'm going to rewrite this as just a 5 to the third power. And now we would figure out what that exponent is. So I bet you all can figure out what 5 times 5 times 5 is. And we know 5 times 5 is 25. Then you have to do 25 times 5. And to help you with that, if you have 5 quarters, how much money do you have? $1.25? So that's just 125. So 25 to the 3 halves power is actually 125. All right, so I just want you to understand this relationship between a rational exponent, a fraction for an exponent, and a radical, the root sign, whereas that denominator becomes the index of the root. Questions at this point? All righty. We're hanging in there. All right, so I'm just throwing in some other special cases you might run into. You don't need to write this whole thing down. This is more just notes for you. Here I've got 49 to the negative 1/2. If you remember our exponent rules, we can't have negative exponents. So if we think of this as 49 to the negative 1/2 over 1, Whenever you have a negative exponent, to get rid of that negative sign, just move that base and the exponent to the other side of the fraction. So I'm essentially just going to move this 49 to the denominator. Its exponent is still going to be a 1/2, but instead of it being negative, it's just going to change to positive. All right, so that's how you get rid of a negative sign, because you can't take something to a negative power. Doesn't really work. So whenever you see a negative, just move that base with its exponent to the other side of the fraction, top to bottom. Or if you get a negative exponent in the bottom, you can move it up to the numerator. Same idea, it's going to switch. And now, just finish this. 49 to the 1/2. I want all of you to figure out what that equals. What's 49 to the 1/2 power? Whatever you get, that goes into the denominator. Yes. Awesome. Good. Yep. Yeah. Nice. All right, looks like a lot of you are catching on. So this denominator becomes the index of a root. So that'd be a square root of 49 to the first power, which is just 49. Square root of 49, we all know that. It's 7. So 49 to the negative 1/2 is 1/7. What's up? Like all those little steps? No, you don't have to. I'm just slowing down. I'm giving you some simplified ones for now, just so you get used to the process. But yeah, if on a test, if I gave you 49 to the negative 1/2, and you knew that was 1/7, write 1/7. It's awesome. Or anytime you see something to the 1/2 power, like you might just get to the point where you realize, oh, anything to the 1/2, it's a square root. So like 100 to the 1/2, it's just 10. So that 1/2 exponent is just another way of writing a square root. That's awesome if you catch on to that already. That's great, Ben. Okay, try this one, everybody. 1/8 to the negative 2/3. So very similar concept. You got a negative exponent. To get rid of the negative, that should be your first goal. Get rid of the negative. Just move that base and its exponent to the other side of the fraction. Then once you get rid of that negative, I have to figure out what 8 to the positive 2/3 is. Exactly, but it's still negative. So you want to move that base, that 8, and that exponent to the other side of the fraction. Now, since it's starting on the bottom, where would you move it? Exactly. So you're going to move that up to the top. And then it'll be a positive exponent at that point. So your first step should be getting rid of that negative exponent. So I'm going to move 8 to the 2/3 up to the top, up to the numerator. And then it becomes a positive exponent. I still have a rational exponent. I still have a fraction. The numerator stays put, but this denominator has to move out in front and become the new index of a root. So that's an index of a 3. So this is a cubed root of 8 squared. Now remember, you can go in either order. I could I know that 8 squared is 64, and then take the cube root of 64. But for me, I always like taking the roots first, because I know that the cube root of 8 is just 2. That's pretty easy for me to figure out, because I know 2 times 2 times 2 is 8. It's just the same as 2 squared. We all know 2 squared is 4. Is that insane that like 1 over 8 to the negative 2/3, which looks insane, is actually just a 4? Math, right? It's crazy. But you could do so much with it. I know you don't see it yet, but trust me, we're training your brain. Questions on any of the steps I did here? Coolio. Even if your exponents are fractions, all those other classic exponent rules still apply. Meaning, if I'm multiplying the same base, see how this is a 2 and that's a 2? We can combine exponents. Do you remember what that rule is? If you're multiplying the same base, how do you combine exponents? What do you do to them? That's right. Exactly, Nick. You add them up. So this would be the same as taking 1/2 plus 5/2, right? You add exponents when you multiply the same base. Like if I had x to the second, just as an example, x to the second times x to the third equals x to the fifth. You would add the 2 and the 3. If they're fractions, you still add them up. Now, when you add fractions, you do need to have a common denominator. Luckily, we do, right? 2 over 2 over 2. So you just add up the numerators. In this case, 1/2 plus 5/2 is a total of 6/2. What's that equal? Yeah, 6 divided by 2 is just 3. This is 2 to the third. Do we know what 2 to the third is? That's an 8. So we can still add exponents even if they're fractions. X to the 2/5 to the 1/4. Now there's only one base, right? And there's a parenthesis here. So when I bring it in, do you remember how we combine exponents in this scenario? Should I add them together? No, what do we do when we distribute? Multiply. Yes, good. That's right. So here, multiply your exponents. When you multiply fractions, very straightforward. You multiply the numerators together, and then you just multiply the denominators together. You don't need a common base or anything. So what's 2 times 1? 2. What's 5 times 4? 20. Can I simplify 2 over 20? 1/10. Good. Last thing we need to do, I have a fraction for an exponent. What do I do with that 10? Where does it go? You can gesture with your hands. You can be like, shoop. Yeah, that index out in front. So it becomes the new index of a root. So this is essentially the 10th root of x, which we can leave there because that's in the numerator. If it were in the denominator, we need to rationalize it, and oof, that'd be crazy. That'd be like combining 2 lessons together. Oh, man. Questions on multiplying rational exponents? Pretty straightforward. Oh, man, just what I was worried about. So a to the 1/3, that's the same as the cube root of a. Right, you take that 3, that denominator, and you move it out in front to the index. That's the same as a third root or a cube root. Now think about the first lesson I taught you today, how to rationalize a denominator. I have the third root of a to the first. Look at that index, it's a 3. I have 1a. How many more a's do I need? What do you think? Show me 1, 2, 3, 4, 5. 2 more. Good. So multiply by a cube root of a squared, because that's going to give me a total of a to the third in the denominator, which is exactly what we want. When we combine those, we get the cube root of a cubed, which just turns into an a because the index and the exponent cancel each other out. The third root of a to the third is just an a. So that's how we'd have to write that simplified fraction of 1 over a to the 1/3. Questions on any of these before going on? All right, try this. X, y to the negative 1/6. So I'm combining a few different properties all in this one problem. And this is it for today. This is the very last problem. Is that negative 1/6 on both the x and the y, or just the y? Ooh. Again, that's one of those common mistakes that I see. That's x to the first power times y to the negative 1/6. So that x is okay where it is. It's the y that needs to flip. So take it from there. How do you deal with that y to the 1/6 in the denominator? All right, so we know y to the 1/6 is the same as the 6th root of y. So we have x over the 6th root of y. This is y to the first power. How many more y's do we need to cancel it out with that index, though? Gotta have a whole 5 of them, right? It's y to the first. I need it to be a y to the 6th. So we're going to multiply by a 6th root of y to the 5th. Our numerator is just x, 6th root, y to the 5th. The denominator, I'm going to have the 6th root of y to the 6th. That's going to turn into just a single y, right? Because if I have 6 y's, how many groups of 6 can we make? Well, just one of them. Yeah, what's up? No, I forget that all the time myself, too. You mean like the index right here? Yeah, if you forget that on the test, that's fine. I understand what you're doing, especially if you multiplied by like a 5. Like that's telling me you know it's a 6th root. So yeah, if you drop this exponent in your final answer, I will not be taking off points. I personally forget it all the time too. It's easier just to write a regular root, but you do need to keep in mind when you're solving the problem that that is a 6th root, right? Because that definitely affects how you rationalize that denominator. Did you do that with the y to the 5th? Awesome. Yep, that's great. Any other questions from anybody? All right. You got some delta math for tonight?